This video is an introduction to RabbitMQ for people who never used it before. RabbitMQ is a messaging and streaming broker that is frequently used for communicating between microservices on the asynchronous path. It is very similar to Apache Kafka in function in the sense that they both use message queues, and we have some services publishing messages to the queues and other services subscribing and consuming the messages. However, RabbitMQ has more powerful delivery mechanisms and it will do some of the work for us. The plan for this video is to first discuss the differences between RabbitMQ and Apache Kafka, then start off a RabbitMQ broker inside a Docker container, and then go over these 5 tutorials from the Get Started. 1, 2, 3, 4, 5, but instead of writing code, I will use the management console from the Docker container, which is this one, for publishing messages to exchanges, consuming messages, and so on. For the second example, this one with work queues, I will use the Python code that they wrote. Here are some example use cases for RabbitMQ and for Apache Kafka. Let's say we have backend monolithic service with some asynchronous operations such as sending emails and sending push notifications. Here we can spin off these two operations into separate microservices. So we will have a microservice that sends emails and a microservice that sends push notifications. And we will send the events to this service via a RabbitMQ or a Kafka queue. So we would push the email events to this queue, and the email sender service will consume these events and actually send the emails, and the same for push notifications. The advantages for this architecture is that, well, first of all, we remove some of the load from the backend monolith, and then we can also horizontally scale one of the two microservices. For example, if we realize that we have a high volume of emails, we can add multiple workers here, and that will make it more efficient. While here, if we don't have enough push notifications, we can leave only one worker. Other examples would be remote procedure calls, streaming, and so on. Now we will quickly discuss the difference between the model of Apache Kafka and that of RabbitMQ. So I made a couple of diagrams for this. This is the model for Apache Kafka. It's a very simple model. We will have a queue and then a publisher microservice. Here it publishes a message with a payload to the queue. Here the queue can have multiple partitions for being distributed horizontally between different brokers. And then we will have consumer services that subscribe to the queue. Here they can all consume the same set of messages depending whether they acknowledge or not, or they can split the messages between the two if they are implementing a worker queue, for example. In RabbitMQ, we also have the concept of exchanges. So now when we have a producer service, it will not publish a message directly into a queue, but it will have to go through this exchange. Now, the exchanges have different distribution strategies, for example, direct, fanout, and topic. So when, for example, an exchange with a fanout strategy, whenever we publish a message to an exchange, it will end up in all the queues that are bound to that exchange. So now there's an additional step. The queues need to bind to an exchange, and after they end up in the queue, we also have consumers consuming some of these messages. Of course, we can have a consumer subscribing to several queues, and also in addition to the payload for a message, the messages will also have an additional field called topic that will be used in some of these strategies for routing the messages to the correct path. So we can see in here how this is more complex, but it does some of the work for us. For example, in Kafka, if we want to fan out messages to multiple queues, we will need to write code in a publisher that writes the message to all these queues in a for loop. But in RabbitMQ, we just configure the exchange correctly, and then it will do the work for us. So this difference is mostly because Kafka has a very simple model, because it was designed to scale to very big systems. Think like big companies in here, Google, Facebook, this kind of stuff, with many brokers. While in RabbitMQ, it is harder to scale horizontally to add additional brokers, but if one broker is enough for you, then you get all this sophisticated delivery mechanism by default, and it saves some of your work. Next, we will start a RabbitMQ broker inside a Docker container on our local machine, and then send our first message to a queue. So if we go to their website, by the way, this is the website I was looking at earlier, it's rabbitmq.com. If we go to getting started, and here, there will be an installation guide. So we can see that this is the Docker image we will run, RabbitMQ 3.13-management. So the dash management part means that it will have the web console that we will use. If you do it without this dash management, you will only have the RabbitMQ broker that you can connect to from your backend with the client libraries. So we will just run this command in a terminal. You will need to have the Docker client installed locally. So in here, actually, I think it copied. No, it should be fine. And we can see that it is starting right now. So if we take a look in here, we see that it exposes two ports, 5672. This will be for the backends and the client libraries. And 15672, this will be for the web console. So once it's started, we can open it in our browser. We just go to localhost 15:15672. Here the username and password are guest and guest. And we will see the web UI. In here, the sections that we will use are exchanges. We can see in here there are already some exchanges pre-populated with different strategies, and queues, and we see that there are no queues at the moment. Now we can work on the first tutorial from getting started. So this one is just publishing a message to a queue using the default exchange. So if we go to the console, we will create a queue in here. Let's call it events. We just do add queue. And remember how in the diagram I said that we cannot publish events straight to a queue. We need to go through an exchange. Well, there's like a special exchange called the default exchange, and in that one, if we add a topic to the message, then the message will be routed to the queue with that name, to the name of the topic. So if we try it in here, we go to exchanges. So this will be the AMQP default. This is the default queue. And in here for routing key, we will add the events, which is the name of our queue. And in here we can say hello world. We publish the message. So now if we go back to queues and streams, we will see that events has one message that was not acknowledged, one message in total. This is the message we just published. So if we go to the events queue, we can see here the charts with the activity, and we can get the message. So by default, it doesn't acknowledge the message. So if we click get message, we see here our payload, hello world. But if we go back, we will see that it still says one message ready, and that's because we have not acknowledged the message. So if we go here again, and under ACK mode, we will say automatic ACK. So now if we do get message, we will get hello world again, but this also consumed the message. So if we go back to queues and streams, we will see that now it says 0 messages that need to be consumed. Okay, so that was the first one of their examples. Now we can move to the second one. This one is about worker queues. For this one, I will use their Python code because it's hard to illustrate in the web console. So the idea with worker queues is that you distribute the work between some services. And let's imagine, so this one would be the producer service, and C1 and C2 are the consumer services. As a hypothetical, imagine we are writing a YouTube copy, and the producer service will be the web interface of our website. So you will have users come in and upload their video files, and video processing takes a long time on YouTube. If you upload a video that has 30 minutes, it might take them like 40 minutes to process. So you cannot have your web interface using bandwidth and hardware resources for video processing. And what you will do instead is the web interface maybe can write it somewhere on the disk and then instruct the workers that there is a file in there that needs to be processed. So it will publish a message to this queue with the path of the video file, and then the workers will have videos processing, and then once they are done, they pick up the next event from the queue, and so on. I will start by adding the consumer code in Python. I will transfer it from this first example. So we need a library for RabbitMQ called Pika in Python. We need to install it with pip. So in the terminal, I'll make a new tab in here. Just create a new directory for this code. Let's call it RB. Here I'll create a new virtual environment with venv, and the name will be venv. Also, I'm going to activate it. We can see in here that it is active now. So now if I do pip install pika to install the library, and I'm going to open this directory in Visual Studio Code, but you can use another editor, whatever you're comfortable with. So in here I just need to transfer the code from the bottom. It will say receive.py. This one from here. We're going to make a new file in here. Let's call it main.py. So in here, line 7, we need to remove because our queue already is created. We don't need to create it again. Here, instead of hello queue, we need to name it events. And here we will simulate some work being done by the worker by adding a time.sleep. So let's say time.sleep 10 seconds should be good. And then let's say finished work, just to see when it finished sleeping. Okay, this looks good. So now I will start 2 instances of this consumer. So in here we would do Python main.py. We can see it's waiting for messages. There are no messages at the moment. And I'm going to create a new terminal window. We'll put them next to each other just to see how the work is being processed. Here I need to activate the virtual environment again. We see it's active. So now we start main.py again, and we can see we have the two terminals waiting for messages. So next we can move on to the RabbitMQ management console. So if we go to queues and streams and our events queue, under consumers, so there will be a section in here, consumers. We can see our two consumers already waiting for events. So we can now publish some events and see how they are consumed. Again, we go to the AMQP default exchange under exchanges. Under routing key, we will do events, and we'll start publishing, let's say, 8 events. So I'll do 1, 2, 3, 4, 5, 6, 7, 8. So now if we open our terminals, we can see that it's publishing the first event, it finished, then it picked up the third event, it finished it, pick up the fifth one, and pretty much the two workers, they take turns, because the events are published in order 1, 2, 3, 4, 5, 6, 7, 8. So then the first worker will pick up the first event, then the second worker picks up the second event. So now they finished all the work in the queue, so they take turns processing the events. Now we can move on to the third example on their quick start. So we can stop this worker, close the tab, and we no longer need this terminal window either. You need to keep the Docker running. So going back to the examples page, the third one is about fanning out events to multiple queues. So here we have a publisher, we publish an event, and it gets fanned out to 2 queues. It's pretty much the fan out strategy. So in here, we go back to the console, we will create 2 new queues. So under here, under queues and streams, add new queue. Let's call this one fanout-1, add queue. And we're going to add another one, fanout-2. And now under exchanges, there already exists an exchange with fanout. We can use that one, or we can create a new exchange. Let's call this one test fanout. And for here, under exchange type, we need to select fanout. We do add exchange. We can see our exchange right here. It says type fanout. And now we need to bind our queues to this exchange. So we go to the fanout1 queue, and there will be a section bindings. So it's under from exchange, we do test-fanout. We bind it, and then for fanout2, we also need to bind this this exchange to the same, this queue to the same exchange. So from exchange, we do test fanout, no arguments, we bind it. So now we go to our exchange that we just created, test fanout. We don't need to set anything under routing key. Let's add a message, let's say first message. We click publish, and we go in here, and we see the message was published to both our fanout queues. If we do another message, let's see, second message, it will take a little bit, but we can see now they both have 2 messages. So fanout exchange is pretty self-explanatory. it pushes the messages to all the queues that are bound to that exchange. Now, if we try to unbind one of the queues from the exchange, so let's say we go to Fanout here, we go to bindings, and we can do unbind. And now we go back to our test Fanout exchange, and we do, let's say, message 3. We do publish message. So we wait a second, and we can see now that Fanout 1 has 3 messages, but Fanout 2, it didn't receive the message because it's no longer bound. Now we will move on to the next example in their tutorial, which is, it says routing. So this one explores what the exchanges with type direct are doing, and also what the routing key, the role of the routing key when we publish a message. And I believe the best example in here is the one with error messages. So in here we have a publisher. This one is an exchange of type direct. And here we have 2 queues. And we are publishing error messages with different log levels. So we will have info, warning, error, and the error type will be published as a routing key. And then the 2 queues, they can have different types of bindings. So let's say one queue only consumes info messages, and the other queue will consume error and warning messages. And then what the exchange with the type direct does, it will route the messages to the correct queues based on the routing key. So we will do this one right now. Let's create two new queues in here. This one, let's call it good messages. And so good messages will, let's say we will publish only info, error messages, log messages of type info, severity, and then we will have bad messages. And this one will be, let's say, error and critical, or warning as well. Let's say warning and error go to bad messages, good messages only info. So in here, we can use AMQ direct, but we can create a different one. It doesn't really matter. So in here in test direct, actually first we need to create the bindings. So for good messages, we will bind from, I think it's called test direct, the one we just created. So the routing key, wait, this one is the good one. So we will receive the messages with info. We bind it. And then for bad messages, we will create 2 bindings. Test direct. And this one will be warning. And we will add another one, test direct, and error. So now we can try out our queues. We go to our exchange we just created to test direct. So let's say routing key, let's say we do error. Let's say in here, this is an error message. We publish this one. So we go back to queues and streams. So we should see it. Yeah, we see it right here in bad messages. Now let's say we publish a warning. Test direct. So routing key, this one will be warning. Payload, you should look into this. And we see we have 2 events in here, and we can consume them. Here we see the first one is this is an error message. Second one, you should look into this. And if we go to test direct and we publish an info message, let's say the server has started. We go back to our queues and we see it got routed to the good messages queue, and of course we can consume it. We see our payload in here, the server has started. And now the last example we're going to cover in this tutorial is this one from here, which says topics, and this one explores the exchanges of type topic. So if we go to the console under exchanges, we can see we have an exchange of type topic. So the type topic is pretty much an extension of the direct exchanges to multiple dimensions. So in the direct exchanges, we can route messages based on a single string. Here the strings can have multiple dimensions. So in here we can see one that has multiple components. It will say stock USD, so this one is the, let's say, the asset type. Then USD would be the currency, and NYSE would be the exchange that is transacted on. And then when we bind queues to an exchange of type topic, we can provide wildcards, and the wildcards can be of two types. There is one asterisk that matches a single component. So in here, if we have this schema, let's say celerity, color, species, asterisk matches only is a wildcard for this component. And then there's also pound, and pound can match as many components as possible. So lazy can match, let's say, lazy dog big, but also just lazy dog. While if we had an asterisk here, it will only match one component. So for illustrating this example, we will use the schema right here. Let's say asset type, then currency. Let's just do these two components. So we will have let's say we will have stock.usd, stock.euro, then we will have bonds, bond.usd, bond.euro. So this will be like the routing keys for our messages. And then we will have one queue that receives all the stocks. So the binding will be on stock.asterisk. Then we will have one that receives all the bonds, and we will have a queue that receives everything in USD, and everything. We will have one that receives everything in euro, and then we'll also try out the pound wildcard. So this will all go in a queue called stock. This will all go in a queue called bond. This will go in a queue called USD, and this will go in a queue called euro. And then we will expand it to adding the stock exchange at the end. So we, in the management console, will create the 4 queues for now. Let's call this one stock. This one will be bond. This one will be USD and euro. And for exchanges, we need to create a similar one. We'll do test.topic. We can also use amq.topic. It doesn't really matter. Here under type, make sure you select topic. We add the exchange. So now we create the bindings. So for stock, it will be, we will add this one will be test.topic. The exchange, the routing key is stock.star. We bind it. Very good. Now we will do the one for bonds. Test.topic in here, and the routing key will be bond.asterisk. Like that. Then we will do the one for USD. The exchange will be test.topic. Everything USD will be bound. And then the one for euro, and in here we'll do test-topic *euro. So we have the 4 queues, and now we can just try out some events in here. And under test.topic, let's say the routing key will be stock.usd. I don't know, Facebook or Google, whatever. In here we publish the message. So this message should end up in the stocks queue and also in the USD queue. So if we look in the stock queue, we see that it made it there. And for the USD, now if we do, let's do a bond in USD. Also in here we do bond.usd. I don't know, treasury. So we'll give it a second. Yeah, we see it made it in bond. And now USD has 2. And let's do something in a stock in euro. Let's see, topic, stock.euro. I hope I made the binding under EUR. Let's say Spotify. I'm not sure if they're in Europe listed. It doesn't really matter. Okay, very good. And we see stock, 2 stocks. So now we will see that if we try to publish a stock.usd.New York Stock Exchange, it will not make it to the, it will not make it to any of the queues, because our binding rules do not allow for 3 components. So if we do stock.usd.New York Stock Exchange, it says message published but not routed. However, if we replace the binding under our stocks, so in here, let's unbind this one. So we will do from test-topic routing key. It will be this time stock, but the £. So this one will match with 1 component, and also with 2 components, with 3 components, and so on. So now if we go back to our exchange, we do stock.usd.New York Stock Exchange, another stock, whatever. We will see that under stock there should be 3. Yeah, it made it to the stocks. And also if we can have more than 1 component in there. So if we do stock USD New York Stock Exchange defunct, whatever, this should make it 4 under this this queue, which it worked as we expected. This is all the material I had for this video. It should be a good starting point on RabbitMQ. If you have any questions or comments, let me know in the comment section below. I hope you enjoyed it. If you want to support the channel, you can like this video or subscribe. Thanks.